9 billion miles from where you are sitting right now, there is a small, frozen world that humanity was told to stop caring about. In 2006, astronomers stripped Pluto of its title as the 9th planet, and for a lot of people, that was the end of the story. Case closed. A demoted rock at the edge of the solar system, too small, too cold, too far away to matter. But somebody forgot to tell Pluto that. Because in the last 2 years, the most powerful telescope ever built by human beings has turned its golden mirrors toward that tiny world, and what it found has left planetary scientists checking their instruments twice, because the data simply should not look the way it looks. This is the James Webb Space Telescope. It sits nearly 1 million miles from Earth, tucked behind a sun shield the size of a tennis court, cold enough that its instruments can detect the faint infrared glow of objects that have almost no heat to give. It was built to stare at galaxies born near the dawn of time. It was built to sniff the atmospheres of planets orbiting other suns. Nobody designed it with Pluto in mind as a headline target. And yet, when scientists pointed it at this small, overlooked world in our own backyard, Webb did something that New Horizons, the spacecraft that flew past Pluto in 2015 and gave us our first real photographs of its surface, could never do. New Horizons gave us a single, glorious snapshot, a few days of close-up images before it slingshot onward into the dark. Webb gives us something New Horizons never could: time. The ability to watch, to return again and again and see what changes. And it turns out everything changes. For decades, the working assumption was simple. Pluto is basically a dead world, a leftover chunk of ice and rock, too small to hold onto much of an atmosphere, too far from the sun to have any real weather, geologically frozen in place since the early solar system. New Horizons cracked that assumption a little, revealing towering water ice mountains, a heart-shaped plain of frozen nitrogen so large it reshaped scientists' understanding of what a dwarf planet could be, and a strange, hazy blue sky wrapping the entire world in layers that shouldn't have been there. But even after that flyby, most researchers still treated Pluto as a place that had already told its story. Webb has proven that assumption wrong in almost every way imaginable. Start with the haze, that thin, blue, multi-layered shroud that New Horizons photographed back in 2015 turns out to be doing something almost nobody predicted. Back in 2017, a planetary scientist proposed a strange idea: that Pluto's atmospheric haze wasn't just a passive layer of particles drifting in the sky, but an active thermostat, absorbing sunlight during Pluto's brief day and radiating that heat back out into space at night, cooling the atmosphere far more efficiently than gas alone ever could. It was a clever hypothesis. For years, nobody could prove it. Then Webb turned its infrared eyes on Pluto and found exactly what the theory predicted. The haze is real, it is active, and it is dramatically colder than anyone expected, roughly 30 degrees Fahrenheit colder than models had assumed possible. Pluto's upper atmosphere sits at nearly -330 degrees Fahrenheit, a temperature so extreme it makes the coldest places on Earth feel almost tropical by comparison, and Webb confirms that this deep chill is being engineered, in a sense, by microscopic haze particles suspended miles above the frozen surface. Scientists are now calling it something remarkable: an entirely new kind of climate system, unlike anything else observed anywhere else in the solar system. Not gas-driven like Earth's atmosphere, not driven by clouds and oceans. A haze-powered climate, built almost entirely out of particles no bigger than smoke, regulating the temperature of an entire world. And here is where it gets stranger. That same haze isn't just cooling Pluto, it's stealing from it. Webb's data shows that high in Pluto's atmosphere, methane and other organic molecules are being kicked loose, lifted up and away from the dwarf planet by these very same haze processes. And where do they go? They don't just drift off into empty space. Some of that material is being pulled away entirely, captured by Pluto's largest moon, Charon, orbiting closely enough that Pluto's leaking atmosphere is quite literally feeding its companion. Picture that for a moment. A small world, barely large enough to be called a planet at all, is losing pieces of its own sky to the gravity of its own moon. It is an interaction that happens nowhere else that we know of in our solar system. Not Earth and its moon, not Mars and its tiny satellites, just Pluto and Charon, locked in a strange, quiet exchange 9 billion miles from the sun, invisible to every telescope in human history until Webb came along and finally caught it happening. Speaking of Charon, Webb didn't stop at studying Pluto's atmosphere. It turned its spectrometer directly onto that companion moon and pulled apart the chemical signature of its surface in a level of detail nobody had achieved before. Charon is a strange, quiet, cratered world, tidally locked to Pluto so that the two of them stare at each other permanently across 40,000 miles of space, like dance partners frozen mid-turn. Scientists already knew Charon carried water ice and ammonia compounds on its surface. But buried in Webb's data was something nobody had confirmed until now: clear evidence of carbon dioxide and hydrogen peroxide embedded in Charon's icy crust. That might sound like a small detail, a footnote for chemists. It is not. Hydrogen peroxide doesn't just sit around on an icy moon by accident. Its presence is a signature of irradiation, of energetic particles and radiation striking that surface over billions of years and rewriting its chemistry atom by atom. And the carbon dioxide tells its own story too, one that researchers believe may be a fossil clue to how Charon formed in the first place, whether it was born in a violent collision with Pluto billions of years ago, or assembled some other way entirely. For the first time, Webb has let scientists read that moon's chemical history like a kind of ancient diary, written in ice instead of ink. But if you want the detail that genuinely stopped researchers in their tracks, the one that made headlines because nobody can fully explain it yet, it's something even stranger than temperature swings or migrating atmospheres. Buried in the infrared spectrum of both Pluto and, extraordinarily, Saturn's giant moon Titan, hundreds of millions of miles away, Webb detected a very specific, very narrow absorption of light at a wavelength of just over 5 microns. In plain terms, something on the surface of Pluto and something on the surface of Titan, a moon orbiting an entirely different planet, is absorbing light in a way that matches no known chemical compound. Not water ice, not methane, not any of the organic molecules already cataloged on either world. Scientists ran the signal against every chemical model they had. They compared it to libraries of known molecular signatures collected over decades of laboratory and observational work. Nothing matched. The researchers who found it described searching through the scientific literature and being unable to locate a single published reference to any known substance that absorbs light at that exact point in the spectrum. Two worlds, unconnected, orbiting different planets, separated by an almost incomprehensible gulf of space, both carrying the fingerprint of a compound that has never been identified anywhere else in the universe. Let that sink in for a moment. This isn't a rumor from an internet forum or a wild theory from a late-night documentary. This is real spectroscopic data, gathered by one of the most sophisticated scientific instruments ever constructed, showing an unknown molecule on two separate icy worlds in our own solar system. The leading candidate scientists have proposed are exotic even by planetary science standards. Perhaps a ring-shaped hydrocarbon called benzene mixed with something else entirely unidentified, or some previously undetected form of frozen acetylene, or a compound built from ketene, a highly reactive molecule rarely found stable in nature. But every single explanation currently on the table comes with an asterisk. None of them fit perfectly. None of them have been confirmed. As of now, this discovery remains an open case file, sitting on the desks of planetary chemists who are, by their own admission, stumped. And what makes it even more compelling is the asymmetry. On Titan, the mysterious signal is stronger on the far side of the moon relative to its direction of travel through space, hinting that whatever this material is, it may be shaped, delivered, or altered by something in Titan's orbital environment, some interaction with radiation or particles that we don't yet fully understand. If that pattern holds for Pluto as well, we may be looking at a process operating throughout the outer solar system that nobody had previously cataloged at all. Think about the sheer strangeness of that idea. We tend to assume that after centuries of astronomy, after landers and rovers and flybys and space telescopes, we have found the basic building blocks of the solar system. We know what ice looks like on other worlds. We know methane, ammonia, carbon dioxide, water. We think we have the periodic table of frozen moons mostly figured out. And then a telescope built primarily to look at the most distant galaxies in the universe turns around, glances at a demoted dwarf planet practically next door, and finds a chemical signature nobody can name. It's a reminder of something documentary narrators love to say and audiences often forget to actually feel. The solar system is not a solved system. It is not a museum exhibit with all the placards written. It is still, after everything, an active mystery, sitting right there in our own cosmic neighborhood, waiting for someone to ask the right question with the right instrument. And Webb is not finished with Pluto, not even close, because unlike New Horizons, which had one shot, one pass, one irreplaceable moment to gather everything it could before vanishing into deep space forever, Webb can look again and again. Scientists plan to keep pointing this telescope at the Pluto-Charon system across Pluto's long orbital seasons so extended that a single Plutonian year lasts nearly 250 Earth years. That means the spring and summer Pluto is currently experiencing, the reason its nitrogen ice is subliming and its haze is behaving the way it is, will not repeat again for centuries. We are catching this world in the middle of a seasonal transformation that no human being alive today will ever see repeat. Webb lets us track those changes in real time, watching volatile ices shift and redistribute across Pluto's surface, watching the haze thicken or thin, watching the mysterious unidentified compound wax and wane, and watching exactly how much material continues leaking from Pluto's atmosphere toward Charon. Scientists have already said that future observations targeting gaps in the current data could expand Charon's known chemistry even further, revealing entirely new processes we haven't even guessed at yet. To understand how strange all of this really is, it helps to remember just how impossible a task Pluto presented for decades. Pluto sits roughly 40 times farther from the Sun than Earth does. At that distance, sunlight arrives so weak and diluted that high noon on Pluto looks, to human eyes, something like a deep, dim twilight here on Earth. Any telescope trying to study it isn't just fighting distance, it's fighting a near-total absence of light to work with in the first place. For most of the 20th century, even our best instruments could only render Pluto as a fuzzy smear of pixels, a pale ghost of a world with no discernible features at all. It took the Hubble Space Telescope, decades later, just to resolve the faintest blotches of light and dark across its surface, blurry patches that scientists could only guess were continents of frozen nitrogen or highland ridges of water ice. It took New Horizons, hurtling past at over 30,000 miles per hour, capturing everything it could in the span of a single flyby, to finally turn that blurry dot into an actual place. A place with names, with mountains called Tenzing Montes, with a heart-shaped plain called Sputnik Planitia. And now it has taken Webb, sitting nearly 1 million miles from Earth in the cold and dark of space, engineered to detect light so faint it makes Hubble's optics look almost crude by comparison, to do something none of those earlier efforts ever could: watch Pluto breathe season after season, and catch it in the act of chemical transformation. That capability matters more than it might sound at first. A single photograph, however detailed, freezes a world in time. Cannot tell you whether what you're looking at is permanent or fleeting, whether a haze layer is thickening or thinning, whether an ice field is growing or retreating. Only repeated observation, gathered patiently across months and years, can answer those questions. And Pluto's seasons unfold on a timescale that makes human patience look laughably short. A single Pluto year, remember, lasts nearly 250 Earth years. The nitrogen ice currently subliming off Sputnik Planitia, drifting upward into gas and feeding that strange, cooling haze layer, is responding to a summer season that began generations before anyone alive today was born, and will not end for generations after we are gone. Webb has arrived at precisely the right moment in that vast, slow calendar to catch the transition in progress, and every additional observation adds another frame to a movie that is playing out far too slowly for human eyes to follow unaided. It is worth pausing, too, on just how unlikely the haze-driven climate model once seemed. When it was first proposed back in 2017, most planetary scientists treated it as an elegant guess rather than an established fact, a way to patch a hole in existing atmospheric models that otherwise failed to explain why Pluto's upper air was so much colder than gas physics alone predicted. Plenty of clever ideas in planetary science don't survive contact with better data. This one did more than survive. It was vindicated in exacting detail, matched almost point for point by what Webb's infrared instruments actually measured drifting above Pluto's frozen landscape. That kind of confirmation is rare and valuable in science because it means researchers now have a working, tested model for an entirely new category of atmospheric behavior, one that may turn out to explain climates on other cold, hazy worlds scattered across the outer solar system and possibly even around other stars entirely. There's something almost humbling in all of this. Pluto was discovered in 1930 by a young farm boy from Kansas comparing photographic plates by hand, hunting for a mathematical anomaly in the orbit of Neptune. For most of the 20th century, it was little more than a faint dot, a single pixel of light too far away to resolve into anything more detailed. Then New Horizons gave it a face. Mountains, plains, a heart carved in nitrogen ice. And now, James Webb is giving it something even rarer. A pulse, climate, chemistry, a slow, strange, ongoing relationship with its own moon. A mystery molecule shared with a world orbiting an entirely different planet. Pluto is not the frozen, forgotten leftover we once assumed. It is an active, breathing, changing world, quietly rewriting the rules of what a small icy body at the edge of the solar system is even capable of doing. So the next time someone tells you Pluto isn't a planet, that it's small, distant, irrelevant, unworthy of real scientific attention, you can tell them this. It is currently one of the only two places in the known universe carrying the chemical fingerprint of a molecule that has never been identified by science. It is feeding its own atmosphere to its own moon. It is running a climate system unlike anything else observed among the Sun's family of worlds. And the most advanced telescope in human history, an instrument built to peer back to the birth of the cosmos itself, chose to stop, turn around, and stare at this small, cold, defiant world 9 billion miles from home. Because even now, after everything we thought we knew, Pluto still has secrets left to give. And Webb is only just getting started listening.